reviewing for our test today. And so, as a reminder, make sure to mark yourselves for attendance. I'll get that squared away in the background. Today, we're actually covering our overall preparations for the test. You can see a bunch of stuff appeared in the classroom. For the remainder of class, we'll actually be going through, I created a jigsaw assignment. And so what that means is we'll use the breakout rooms. Everyone will become masters of a certain part or aspect of their assignment. And then once they get that taken care of, I'll then go through and hit shuffle on all of the rooms. And that shuffle will allow everyone to then teach each other, teach them what they learned and all of that. But to start off, I kept track of all the misconceptions that we covered and had throughout this unit. So that's what I'm going to go through and present on. So we get that up and going. And if you have any questions, you can always just throw that in the chat. Otherwise, at the very end, there will also be time to ask additional questions as well. So for our major misconceptions, this was all kinds of observations and things that I pulled from our overall unit. You may remember that I periodically polled everyone. This was why, so I could see what we knew, what we didn't, and any potential mishaps that we had. So our very first section, we were covering matter, mixtures, and substances. One of the first things I noticed is this question was pretty much missed all across the board, and that was, what does this diagram represent? And so when we're talking about atomic diagrams, any of those individual little spheres is kind of representing an atom. And so because all of these atoms are just floating on the very bottom of our actual container, that is representing of a liquid. And so the reason it's liquid is because, well, all of the atoms, they don't really have any form. They're not super condensed together in kind of like a crystal-like structure, as would be more typical for a solid. And if it was a gas, it wouldn't all be kind of held by gravity on the bottom. You would see all the spheres just kind of freely floating up, and they could really theoretically be anywhere and not just within the container. And so that was the first misconception I wanted to iron out, is that this diagram is talking about liquids specifically. And so the big thing is that liquids are free-flowing, but they have definite volume, so they'll always fall to the bottom and cluster there. And then, as I mentioned, atoms in a solid formation are all going to be touching and condensed. Anything that's floating freely within that diagram is going to be a gas. The next misconception was, what is the difference between a mixture and an element? So specifically, a mixture has all kinds of different substances, compounds, and atoms within it, and they can be separated by physical means. That's very different from an element, which is always a single substance. This substance can either be just a singular atom or a molecule. And so the biggest difference between an element and a mixture is elements are going to be pure and have the same chemical properties for any sample size, while mixtures themselves are not pure and are complex, meaning they have a bunch of other stuff and different things mixed in them. Those were pretty much the main misconceptions from our very first part and lesson. The next lesson is we were talking about atoms and their actual parts. And so when we're talking about what is actually inside of the nucleus, which is the core of our atoms, that is only going to be protons and neutrons. All of those electrons, again, are floating in specific orbitals. They are not bound at the very center of our atom. And again, we also talked about that proposal for electrons is there's a small but notable percentage in which the electrons might not even be in that orbital. So if a question was posed that states what specifically is in the atomic nucleus or the atomic core, that answer is going to be protons and neutrons. So then this question also tripped up a few people. Is I asked, what is the majority of an atom made up of. And so this was referencing like how big an atom actually is, with the reality being with those electron orbitals on the outside, they're actually super far away from the actual nucleus. And so a majority of the atom is only going to be made up of empty space, because of the fact there is such a big difference between the actual possibility and those shells that those electrons can be in and their distance from the nucleus. In the video, this was talking about the Edpuzzle, where it talked about that kind of strange quantum zone. The reason that the majority of the atom is not made up of any like quantum material or anything like that is because, as kind of a small little inference into quantum mechanics, everything in quantum mechanics is tied to time, and so it can be temporary. It's not always there. Sometimes it is, sometimes it's only there for a certain amount of times. So when we're talking about what makes up a majority of the atom, the only thing that's going to be there is space, because we're also not getting into quantum mechanics, as that gets much more messy and much more complicated. And so I kind of condensed that all the way there at the bottom for you in a basic definition, is for a majority of the time, there's just going to be empty space. Sometimes strange stuff might happen at the quantum level, but again, that's getting into quantum mechanics. That isn't a true definition about how that is going to happen. This moves on into section 3, talking about the Big Bang and forging the atom. And so there were a fair amount of students who sent me questions and curiosities and points of information, as they were a little bit confused about the definition of the Big Bang. And so I wanted to iron it out. Does the Big Bang Theory explain how the universe began? And so some students either in class or afterwards were thinking about this and thought that the Big Bang Theory stated how the universe started. Specifically, when we're talking about science, any scientific statement has to meet the following requirements. It has to be observable, testable, experimentable, and falsifiable. What that means is, for any scientific statement, one, you have to be able to observe some part of it. And so when we're talking about atoms from before, our initial people and their theories behind atoms weren't accepted by the science community because there was no observable piece that they could see. They didn't have the tools for it. It has to be testable, because you can't just state, oh, as an example, atoms are made up of thoughts. Like as an example, like you think that something is there, so you touch something. That isn't exactly testable because there's no way to measure that. There's no actual restrictions on how to create that kind of experiment. Hence, it also has to be experimentable. You can't simply say, when you're talking about like the Big Bang, for example, you can't state that because nothing was there, everything was created. Like, you can't really test that kind of explanation. You can't test that kind of proof. And so there has to be an experiment you can actually conduct in order for that to be true. Falsifiable means that anything you state, there has to be restrictions. And so when we talk about like the forces from Newton, or we're talking about gravity, there should be like some kind of either equation or some system that if this happens, this should happen. So then in the real world application, if you do that thing, you should be able to create a predetermined result. And so what all of that means is the Big Bang Theory states simply that there was a Big Bang. And from that expansion, things began to cool, our base forces then began to form. The actual Big Bang Theory explains what happened from that point and moving forward. The theory itself does not explain what caused the Big Bang, because we don't have tools that are advanced enough in order to make that kind of scientific statement. If we had some kind of scientific statement for what made the Big Bang, it would have to be observable, testable, experimentable, and falsifiable. And so, in a strange twist, in order for us to have any form of scientific statement on what started the Big Bang, we would have to essentially be at an advanced enough level to essentially create a whole entire separate universe. Because of the fact that if we state and observe that the Big Bang has created everything to now, the only way to make a scientific statement about what started the Big Bang is to essentially create a universe 2.0 as an experiment. And obviously, we are nowhere close to even having those tools to be able to do so. So when it comes to the Big Bang Theory, it's explaining what happens from the start up till now. It really doesn't even explain what that start was, because we don't have the tools to be able to do so. Moving on to our timelines. There was also a bunch of confusion when it came to our timelines in creating everything that was there. There was some confusion about hydrogen and helium and what exactly forces were. There was also confusion on what particle physics was. There was also a few interesting notes about protons and neutrons combining. There was also some confusion about where hydrogen and helium fell into place. And so the biggest thing that I wanted to note is hydrogen and helium being elements. Elements and forces are two different things. Elements are specific forms of atoms that are unique and have specific properties, versus forces, which are universal and act on everything. Kind of think of the difference between gravity that keeps you on the planet, that's a force, while aluminum foil is potentially a pure element of aluminum. And so when I ask for two forces, it really doesn't make sense to use hydrogen and helium because forces are not found on the periodic table. The confusion that we have down here is some people put hydrogen and helium for that circular motion. If that was the case, if this cycle continued, we would only have hydrogen and helium in our universe. And obviously, we do not just have hydrogen and helium. Only one of those elements is even a single part of what makes us human and is fundamental particles. So the other thing that I wanted to iron out is what exactly those particle physics were. I realized in my explanation, I never went through in depth on those four forces. They were referenced a lot in your Edpuzzle videos, but particle physics is referring to the four fundamental forces of the universe. And so those fundamental forces you can see on screen. I also included a link for more information in case you want to be able to determine those differences better. Gravity, I'm sure you've heard of that force. Gravity acts on everything. The strong force is referring to the actual force between protons and neutrons that keep an atom together. Electromagnetism is referring to magnetism and light. The weak force is referring to the forces that interact between atoms. So strong force is specifically inside the atom. Weak force is outside the atom. And so particle physics, I'm talking about four major forces. So when I was talking about what forces are in check, when it comes to our timelines, that was talking about gravity and pressure for stars, because these other smaller forces like the strong force, electromagnetism, and weak force, because we're in such a dense state for plasma, those forces are being overridden for the most part. Hence why we talked about how stars were super, super intense. Moving on to our atomic history, the plum pudding model had a lot of confusion. And so that model and the idea behind it is that all of the electrons are just caught inside of some kind of positive matrix. So if we're thinking of an analogy, the electrons would be like chocolate chips inside of a positive proton muffin, is essentially what the explanation was. The plum pudding model was our first idea behind electrons, as we had hinted at the fact that they exist, but this model was not testable, and hence why there was no change as positive rays were going through it, because this was one, just a theory, but two, as we found out from the other model, that was actually incorrect. And so The other main 3 stages I wanted just to reinforce is, again, the plum pudding model. We had found electrons, which revealed to us kind of the first piece of the atom. That was our first piece that we had found. What happened at the next stage was the Rutherford gold foil experiment. This is where we found out that the nucleus is dense and positive. This was also our first experimental proof we had on the atom. And then our quantum mechanical model then proved that the nucleus is made up of protons and neutrons. And so if we're talking about like 3 of the most important things to know with the overall history of the atom, these stages essentially were our final proofs into 1, figuring out one of the fundamental pieces of an atom, 2, figuring out that the atom is a superdense nucleus with electrons around it, and then 3, finding out that nucleus is made of protons and neutrons. The last section, which we just had, was the periodic table, and the only real confusion is groups versus periods. And so period, again, is going to be every horizontal row versus a group which is going up and down. So again, periods are your horizontal rows. Groups are going to be your vertical columns. Beyond that information, does anyone have any questions or any other misconceptions they wanted to get ironed out?